Hello everyone, welcome back to our channel, Madesimplewithus, and I'm Kalawa. Today, we are going to learn about how we can find the inverse of a 3x3 matrices. Whether you are just curious about matrices or you are a student, this video is for you. First thing first, let's understand the inverse of a matrices. The inverse of a matrices is always denoted as A equals to, or A raised to the power minus 1. So this is the inverse of a matrix. This is always denoted. And it's always equals to 1 divided by the determinant of A multiplied by the adjoint, or we say the cofactor. That is, when multiplied with A, that is the matrix A, results in the identity matrix. The identity matrix is always 1, 0, 0. That's it. So this is how you determine the identity matrix. Now, the process of finding the inverse of 3x3 matrix. The first step is we are going to determine the determinant of the matrices. For example, if we are given a matrix to be A, B, C, D, E, F, G, H, this is 3x3 matrix. Remember also the sign minor for a 3x3 matrix. So the sign minor for a 3x3 matrix, it is always denoted as plus, minus, plus, minus, plus, minus, plus, minus, plus. So this side is very important in solving the determinant or finding the inverse of a 3x3 matrices. Note, in finding the determinant of a 3x3 matrix, note, you choose any row for the matrices. That is for matrix A. Derive the minor from each element in that row. That is, for example, from this elements, A, B, C, you are going to choose any row. Remember, these are the row. You are going to choose any row, and in each row, there are 3 elements in each row. So you are going to use those elements in determining the minor, or in determining, or in arriving at the determinant of a 3x3 matrix. So let me take the matrix again out. A matrix is equals to A, B, C, D, E, F, G, H, I. So from this element, we are going to determine the minor of the chosen row, which you have chosen already. So for me, I'll go in with the first row, A, B, and C. So I'm going to find the minor for this. So remember the minor sign. So if I'm going to find the minor for A, let me take A out. So the minor for A now is going to be, remember, in our previous video, when determining the determinant of a 3x3 matrix. So in finding the minor of a 3x3 matrix, let's see, from the chosen row, the first element here is A. So from A, we are going to take note of the column in which A is connected and the row in which A is connected. This is the row and this is column. So once we have determined the row and the column, we take them out. Whatever that is remaining, or whatever that is remaining, it is known as the minor. So we can see that the remaining here is E, F, H, I. So this is the remaining. So therefore, the minor for A is E, F, H, I. So this is minor for A. And we are also moving on with the sign minor. So if here is positive, we are moving now to B, which is the second element in the row. B is supposed to be negative, minus B into Again, for B also, we do the same thing. The same thing occur. For B also, we determine the column in which B is connected and the row in which B is connected. So once we determine that, whatever that is remain, it is known as the minor. So what is left out is D, let me change in D, F, G, I. So this is the minor for B. And we also follow the minor sign. This is going to be positive C, because we are moving on to C now, right? So again, from the column, from the row which we have chosen, we now find the minor for C again. Let's determine the minor for C. So we are going to determine the column in which C is connected, and we also determine the row in which C is connected. So whatever that is remain, it is known as the minor. So this is the remain. So these elements are known as the minor for D. So this is going to be D, E, G, H. So we have now determined the minor of each element from the row that we have chosen. So from this one, we now find the determinant of each of these elements. So we are going to find the determinant. So if we are going to find the determinant of A, this is going to be, remember, in finding the determinants, we always multiply the corresponding element and subtract the other corresponding. So we go, this is going to be E multiplied by I is going to be EI minus F H. Remember, this is positive, so this is A, this is positive. And then we move on to B minus B. It's going to be that. It's again, we take the corresponding, multiply them and subtract. Also, this again corresponding. So this is going to be now, for B elements, the determinant here is going to be DI minus FG. And then plus C. And then C, what do we have for C? We have DH minus AG. So this is what we have for I. So from this, we can find the determinant, but we already have letters, so take notes. So this is how we are going to find the determinant for 3x3 matrix. So the second step now, we are now going to determine the cofactor or the adjoint. Now, in determining the adjoint or the cofactor, there are steps you must follow. So let me go to step. This is step 2. We say we now determine the cofactor, or we say we find the cofactor, or we call it adjoint, or the adjoint. Now, in determining the adjoint or the cofactor, there are also steps here you must follow. The first step is we must derive the minor of each element. Here we are going to derive the minor of each element. And how many elements do we have? Here we have 9 elements. So we are going to derive the minor of each element. We have 9 elements. So we derive the minor. We derive the minor of each element. And the second step is we find the determinant of each derived minor. The second step now is we find the determinant of the derived minor. And the third step, we apply the sign minor rule of 3x3 matrix. We apply the sign minor rule of 3 by 3 matrices. And the final step, now we transpose the derived variable new matrix, that is the row is going to be transposed as the column. So these are the steps you must follow. Example. From this example, we are going to follow all these 4 steps and determine the determinant of 3 by 3 matrix. The example is saying, find the determinant of A given that A is equals to 1, 0, 2, 3, 0, minus 9, 5, 8, minus 1. So this is the example. Solution. Remember that the inverse of A, let's take up the formula, is always equals to 1 divided by the determinant of A multiplied by the cofactor. Or we say the adjoint. So this is the formula. So let's determine each element in the formula. The first step is, let's determine the determinant of A. So the determinant of A must be equal to, so in order to find the determinant of A, we take any row, empty element, that is, we can take row or column from the matrix. So we are going to find the determinant. Let me just take the elements out so you guys can see clearly. So A, 1, 0, 2, 3, 0, minus 9, 5, 8, minus 1. So this is the element. These are the elements. So from here, we are going to determine the determinant of A. And remember, I'll always take in for the first row. So let me find the determinant. So in order to find the determinant, we first, remember, we first going to find the minor of each of the 3 elements. So the first element here is 1. So let us determine the minor for 1. And remember, it has a sign here as positive. So the minor for 1 is going to be, we close down the row, the column, and close down the row. So what is left out is 0, minus 9, 8, minus 1. So this is what is left out. And then we have plus false, 0. We find again the minor for 0. Remember, if we are going to find the minor for 0, this is going to be this is going to be, we take out the column, also take out your. So what is left out is going to be now 3 minus 9, 5, and so on. Then we move on to and this is supposed to be negative. Plus negative was supposed to be negative. We move on to 2. So 2 again, we take out the column, and you take out the row. So what is left in there is 3, 0, 5, 8. So this is what is left. So this is going to be now positive 1 again, and then we find the determinants for them. That is 0 times minus 1. This is 0 minus, and then 8 times 9 is supposed to be 72 minus 72. And we have minus 0 again, because 3 times minus 1 is going to be minus 3, minus into 5 times 9 is going to be minus 45. So it's close. And we have positive 2. 8 times 3, 24. Minus 5 times 0, this is 0. So we go again, is going to be positive 1 and 2. This is what 0 minus times minus is plus 72. This is minus 0, so it's going to be minus 3. Minus times minus is plus 45. Plus 55. And we have here plus 2. It's going to be 24. So it's going to be plus 1. It's going to be now 72. 0 plus 72, 72. Minus 0 into minus 3, 45. This is 42. Plus 2. This is 24. So we go again. Plus 1 times 72. It is 72. This is minus 0. This is plus 2 times 24 is 48. There is going to be 72 plus 48. So this is going to be 120. So the determinant of A is 120. So that's the determinant for A. It is 120. So this one is clear now. We have already got the determinant of B, 120. So now the next step is we are going to find the cofactor. I'm going to find the cofactor. I will say the adjoint. The cofactor or the adjoint again. So let's take from A, the matrix. Let's take the original question again. This is 1, 0, so 3, 0, minus 9, 5, 8, and so on. So this again is going to be the same. We are going to find the determinant. We're first going to derive the minor for each element. This one you don't choose whether one row. You are going to find the minor for each element. That is for each of the 9 elements. We are going to find the minor. So if we go again, let me go straight, because this one is too lengthy. So if I'm going to choose 1, so I'll close this part, and this part close. So what is left now? It is. You just need to find the minor, so this is going to left with 0, minus 9, 8, minus 1. We flow with the sign. If here is positive, here is supposed to be negative. So we go again, find the minor for 0. So we're going to find the minor for 0 is going to be, we take this out, we take this out. So this one, we take them out. So what is left here is 3, 5, minus 9, and so on. So that's it. We go again, we find the minor for 2. So just take them out and take them out. So what is remain? Remember, this is going to be positive. So this is going to be 3, 0, 5, 8. We go again. This one is too lengthy. Find the minor for 3, 2. It's out. What is remaining is 0, 2, 8, and so on. It's left to be negative. Plus. So go again. We'll find the minor for 0. So this take them out, let's take them out. What is remaining? This 1, 5, 2, and so on. And it's going to be negative. And we find the minor for 9. So this is find the minor for -9. This is going to be take this out. It's going to be 1, 0, 5, 8. Move again. Find the minor for 5. This again is out. So what is me? It is 0, 2. 0 and a slide. So it go again. We'll find the minor for 8. 8 again, this cancelled. What is left is just follow the sign rule. It's going to be minus. And this is going to be now 1, 2, 3, and 9. 1, 2, 3, and 9. So we go again for the final one. And this is -1. So the minus. So what is left? It is 1, 0, 3, 0. So you follow again with the sign 1, 0, 3, 0. So we have find the minor for each of them, each of the 9 elements in the A matrix. So after which we now find the determinants of them. We derive or we determine the determinants and the determinant of each of the elements. The determinant of each of the elements. So I want to multiply. It's to this, it's to this, it's to this, it's to this. So this all I'm going to be dealing with it. We are quick. Very, very quick. I don't want to waste time again. So this is going to be now 0 plus 72. Then this is -3 plus 5, 24, 0. And this is 0 and 16. And this is -1, -10. 8, 0. This is 0, 0, -9, and 6. It is 0, 0. Again, we follow the sign. You must always move with the minus sign. Move with the minus side. Move with the minus side. Continue to move with the minus sign. So now let's place the minus sign. This is plus, minus, plus, minus, plus, minus, plus, minus, plus. So move with the sign. So now let's clear the brackets. So if we clear the bracket now, this is going to left with 32. This is 42. This is 24. This is -16. And this is -11. This is 8. This is 0. This is -15. And this is 0. Remember to move along with the minus sign. So let's move with the minus sign. So put this in brackets, brackets, brackets. Because we want to move with the minus sign. So we are going to move with the minus sign. This is going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. Always move with the sign, with the minus sign. That's the rule. So if we move the minus sign, and it's going to be now plus times plus this is 72. It's going to be minus 42. This is positive 24, positive 16, minus 11, and this is minus 8. This is 0, it's 1, 5, this is 0. So this is not the final answer. So this is the cofactor. This is actually the cofactor. The cofactor of A. Now, to arrive at the cofactor of the determinant now, we say we should transpose. We are going to transpose. That is all that is in the row, we are going to put them as column. And all that is in column, we are going to put it as row. Remember, the row here, these are the row. So this is row, O1, O2, O3. And these ones, they are the column C1, C2, C3. So we are going to interchange the row and the column. So if we do the interchangement, this is going to be, remember this is row. This one, 72 minus 42, 24, they are in a row. So we are going to place them now to be in column. So that's the rule. You see, we transpose. We transpose cofactor. I will say the adjoint. So if we do the transposition, this is going to be now 72 minus 42, 24. Remember, this was in the word. Now we are placing then equal, and this is only then going to be 16 minus 11 minus 8. This again going to be 0, 15, 0. So we have definitely transposition. So this now is the final cofactor of the determinants. So meaning we have now ascertained the determinant. That is from the inverse of A, which is 1 divided by the determinant of A multiplied by the cofactor. So we have ascertained the determinant to be 120, and we have now ascertained at the cofactor. So I'm going to multiply this. We're going to split them now according to the formula. So this is going to be now, hence, this is going to be, the inverse of A now is going to be 1 divided by 120 multiplied by the cofactor now of the inverse, which are 72 minus 42, 24, 16 minus 11 minus 8, 0, 15, 8. So this is the setting. So from which we're going to multiply again with determinant. Oh God, this is a very, very lengthy topic. So we're going to multiply this into this. So, okay, let me just set it and I'll stop here because the video is too long now. It's too lengthy. So this is going to be now 1 divided by 120 multiplied by 72, 1 divided by 120 multiplied by 16, 1 divided by 120, 0, 1 divided by 120 multiplied by 142, 1 divided by 120 multiplied by, this is too lengthy, 11, and it's 1 divided by 120 multiplied by 15, 1 divided by 120 multiplied by 24, 1 divided by 120 multiplied by minus 8, 1 divided by 120 multiplied by 0. So you guys can do the completion. This is how you solve for 3 by 3 matrix inverse. This is how you find any given 2 by 3 matrix if you ask you to find the inverse of that matrix. So follow this step and This is Madesimplewithus, and I'm Kalawa.